CO2 you captured in your plant is in the gas phase. With carbon capture technologies and further processing, the percentage volume of CO2 is concentrated to above 90%. This CO2 entering the network of pipelines meant for carrying CO2 carries it to clusters, hubs, and eventually to storage and utilization locations. This CO2 gets pressurized and turned into liquid-like form, often called supercritical CO2, with physical behavior like density of liquid and viscosity of gas. Liquid CO2 is approximately 500 times denser than the gaseous CO2, so you can better utilize your pipeline capacity. To understand phase behavior of CO2 and regulations in place to accurately measure CO2 captured, now we head to Oliver and Arjan.
Thank you, Janice. Oliver, can you explain the phase behavior of CO2, please?
Yeah, sure can. For that purpose, let's have a look at the phase diagram of the CO2. If we look at CO2 at ambient conditions, then it behaves as a gas. We all know it, we all hear about it. So it's in a concentration of maybe 380 ppm in our air that we're breathing. And if we cool that stuff down at ambient pressure, we need to go down to minus 78 degrees C, where it becomes dry ice. So unlike water, it doesn't become first a liquid and then you can solidify it to ice. No, it directly turns into a solid. So this behavior, you call that phase change resublimation. And if you convert the dry ice back to a gas again, you call that sublimation. So this is a highly interesting behavior of the CO2. We need to increase the pressure up to 5 bar plus in order to reach the triple point of the CO2. And as of this pressure, we're able to convert the CO2 to a liquid first and then solidify it. So this is very important if we want to transport CO2 in the liquid stage. Later, if we increase the pressure even further and we go to around 74 bar, we're able to reach the critical point. And above the critical point, we reach a state that is called the supercritical CO2, the supercritical phase. And this is highly interesting. You only have a single phase. That means you can change pressure, temperature, play around with it, but you can't create a second phase. It's impossible. However, that supercritical phase is highly interesting because the density is somewhere between liquid and gas. The viscosity is also somewhere between liquid and gas, but the solubility is very good. So you can use this supercritical CO2 as a solvent. That means you can use it, for instance, for enhanced oil recovery. You can use it for dry cleaning as an example. So that was it about the phase diagram of the CO2. And now I've got a personal question myself to you, Arjan, because I'd like to know about CO2 if I'm now selling it, if I'm purchasing it. So from tax perspective also, if I'm doing custody transfer of that stuff, what do I have to keep in mind? Could you tell me about that, please?
Well, Oliver, this depends on two main things. First of all, where does the tax payment take place? So which country this would be. And second thing would be important in which physical states the CO2 is in. So when we look at point one, the location determines the regulations to comply with. Globally most accepted are the OML recommendations. Many local and regional regulations are based on this, like the European Measurement Instruments Directive. As to point one, the location determines the regulations to comply with. Globally most accepted are the OML recommendations. Many local and regional metrology regulations are based on this, like the European Measuring Instruments Directive, the MID. So if we would be in Spain, the MID would apply. If we were in Oman, for example, the OML would apply. When we then go to point two, the physical state of the CO2, we look at it in two different ways. On the one hand side, we got gas dense and supercritical, a gas form. In the other hand side, we got the liquid form. If it is in the liquid form, and for Spain, the MI 005 would apply. Then we would need a type approval for the instruments, and we would need a system certificate according to the accuracy class 1.5. If we would go for the gas dense and supercritical phase, so the gas forms, in Spain, MI 002 would apply. However, MI 002 only applies to flammable gases. CO2 is not a flammable gas. In that case, Spain would have to look at the OML recommendation 137 for gas forms, also supercritical. Endres and Hauser recognized this issue, so the PTB has issued us a type approval for our PROMAS F, X and O according to MI 002 for non-flammable gases, so for CO2. So that would mean that Spain can still apply MI 002 for their metrology regulations. If you would go to Oman, then the OML R137 would apply.
Thanks a lot for this clarification, Ian. Highly interesting stuff. I mean, these regional differences also explaining, the different phases where the stuff could be very interesting. I learned a lot, and I think people around the globe also have learned a lot in this session from you. Thanks a lot. And with that, I'd like to pass back to the studio to Janish.
In the previous section, you understood how the phase behavior of CO2 changes with changing pressure and temperature conditions. Regardless of your industry or the ambient conditions, the goal is still to accurately measure CO2 which you have captured from your plant. We looked at how to accurately calculate CO2 in different phases, at the same time comply with local regulations.